talking about exceptions in our code, and yeah, let's not do that. Oh yeah, I want to just make a copy of the parking lot folder. Oop, exceptions. Alright, so let's open up parkinglot.cpp and parking sandbox. Alright, so with the parking sandbox, oh gosh, that's true, that's a really big file. Alright, that's what I did on Monday. Alright, let's actually make a copy of that, and I'll do something else with that. Copy parking sandbox to parking sandbox simple.cpp. Alright, and what I'm going to do in this file is I'm just going to create some. Ooh, that was some good code right there. Let's steal that. Let's delete like most of this code. Alright. Alright, so there we go. So there is my economy parking lot, and let's just change that so there's only 2 spaces. Oh, we need a main here. And if we do an A dot, let's see, what did I call that? Car exit. All right, let's see what happens when I compile that now. So G++ parking lot, oops, parking lot.cpp, and then parking sandbox simple.cpp. Compile that, run that, and you can see it says no cars to exit. All right. So in this situation, this is doing stuff to see out. Okay. This is the method that I originally chose because it's pretty obvious. So what I'm going to do is I'm going to change this code a little bit to use the assert statements, and I want to just show you this just because you are probably going to see this. If you take data structures in the fall, this is how we do these sort of exceptions. But C++ has another method of doing it, and let's see, where is it? Right here. All right. So cout, sorry, lot full. All right. So one other way, and actually, why don't we just do this? I'm going to make a copy of this car enter function and write the other way to do it. All right, and I'm just going to comment all of that out. Okay. So what I want to make sure here, all right, and assert is a function, all right, and whatever you give it should be true, okay? If whatever you give it is false, it's going to immediately stop the program, okay? So what we want to assert is occupied is less than numspots, okay? Because if occupied is equal to numspots, I can't have a car that enters. Okay, obviously, if occupied is more than numspots, that's a very bad situation. No idea how that happened, but that's also not supposed to happen. All right, and assert is going to immediately exit the function. So what I can actually do is not do anything whatsoever, and just go back to that. All right, so let's just make sure that occupied is less than numspots, and then let's keep on going. Okay. And now let's recompile this and let's see what happens. Yeah, assert's not mentioned, so now I have to try to remember what a stat is. Is that one? Yay, okay, all right. And now when I try to run this, it does the exact same thing. Why did it do the exact same thing?
Is it other way to do
Ooh,
it.
because I did car enter. Because I called car exit, not car enter. Whoops. Okay. All right, so there's only two spots. A dot car enter. All right, that one should work. A dot car enter. That car should work, but A dot car enter again should not, because there's only two spots available. Okay, so let's see what happens now. All right, so earlier we had the no car exit, that's the cout method, and now you can see that this is the assertion failing. All right, parking lot.cpp line 79 bool blah 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 assertion occupied is less than num spots failed aborted core dump. So this is like hard stop the program. Things were just not the way they were supposed to be. You got to fix this problem. Okay.
That's like a warning.
Well, this isn't like a warning. This is more like because this completely stopped the program. There wasn't any recovering from this. All right. So asserts are very, very good to put in for you as the programmer to make sure that life is good. All right. Like, hey, I'm not supposed to have this number is never supposed to be negative, but it went negative, so something's going wrong. Okay, like cars are entering and exiting, so we just figured out that something is incorrect. This is also a way of sort of defensively programming. All right, this will make a little bit more sense in data structures, but you're going to be creating queues, removing queues, and you want to make sure that that data structure is in such a form or has values in it that you expect. Because if they're not what you expect them to be, then something is going wrong, and you just want to stop the program right there so that you can figure out what the bug is. Okay, so this is one situation that you can make sure that your programs are working properly. The problem with this assert is you can't really recover from this. Okay, the program has exited. It'll tell you like, hey, it crashed. No, it crashed. I mean, it exited on line 79. You probably wrote that for some reason, so therefore you should go back in your code and fix that. Okay. So that's the assert method. All right, halting execution with assert. All right, and the last one is error handlers, and this is the one that we're really going to talk about today, which is the way that C++ can do it. We'll put it that way. All right. So first thing is notice that we have to do it. This is by the way how we can throw a logic error, throw an error. All right, and we have to include std except. All right. What this also means is exception handling, because it's a pound include. This sort of feature is only in C++, which turns into to be its Achilles heel. You'll see in a few slides. All right, but this is how you can actually use exception handling in C++. Obviously, pound includes std except, all right? And then we have just some place in our code where we want to say, hey, if a is equal to 0, that's bad, all right? If that's bad, I want to throw a logic error and just let the user know or the rest of the program know that bad stuff happened, okay? And the way that I do that is with this syntax, throw and then some error with a string in it, okay? Now for our purposes, we're not going to be dealing with other types of errors. We're just going to deal with logic errors, all right? And then we can throw a logic error, okay? Yeah? Well, it replaces the cout for error type stuff, yes. All right? And then you can give it sort of like a string description about what happened, okay? Oops, sorry, wrong way. All right, so throwing exceptions and catching exceptions actually are sort of paired up together, all right? So back when I talked about that assert statement, as soon as I say assert, okay, the program is going to completely stop. There's no way of recovering from that, okay? C++ exceptions allows for a way to recover from something bad that happens, okay? And the way we do that is we call this a we call this a throw catch sort of situation, all right? And we do that, we catch an exception using a try catch block, okay? So what we do is sort of like akin to sort of like baseball in that you have some function or some piece of your code throwing an error, okay? And then something farther up in your, or down, however you want to think about it, needs to catch that exception and deal with that somehow, okay? So this is what this try-catch block exception looks like. In main or something high up, you're going to have what we call a try-catch block. And try is going to run some code, okay? And then if anything goes wrong with this code, meaning it throws an exception, it's going to call one of these exception handlers, okay? So for example, if some function, this is sort of matched up to these slides, all right, I'm calling some function and I should never be given the value 0, but what if I did give it the value 0? Then it's going to catch that exception and call the logic error right here, all right? And then it's going to run this code, okay? And that might actually print something to the screen, might try to, I don't know, try to recover from that bad situation, all right? Now there's multiple types of exceptions. The one that we're going to deal with in this course are just plain old logic errors, but realize there's a bunch of other types, all right? And that this is sort of like a catch-all way to do it, all right? So, your question? Yeah?
Go ahead.
Okay, so this is a logic error. There's also like a file I/O error, all right? So what this allows you to do is like, hey, if a logic error happened, do this. I could have another catch that said, for file errors, do this. For another type of error, do this, okay? The sort of catch-all is this exception down here at the bottom. And anything is going to be caught right here, okay? The way I sort of think about this is like a pitcher and a catcher, in that some part of your code is going to be throwing an exception, and something has to catch that before it like pops out of main. Okay? Some of these catch blocks, like logic errors, this is a glove that only catches softballs. Okay? This exception is a glove that catches any type of ball. It could be a softball, could be a regular baseball, it could be, I don't know, another type of ball, maybe like a soccer ball. If you're really going to catch that with a baseball glove, I guess you could. All right, but this will catch anything. Okay? So this is sort of like how we typically do this in C++. All right? So with a throw and a catch. So when errors occur, throw an exception. All right? The exceptions will go up the call stack until something successfully catches it. Okay? All right? Multiple catch types allowed to match a specific type of exception. If no catch matches, it will stop the program. Okay? So for example, if we had this code, all right, and we had nothing higher up in the call stack that did any sort of try and catch, it's going to immediately stop the entire program. Okay? So you sort of have to write into your code that, hey, this actually needs to do something with this. All right? All right, so let's actually start to change this. All right, so include std except. And now I'm going to put in this try catch block. So try, I'm going to put all that in there. Oops, wrong way. Let me just make sure I get this right. All right, so that's how you could do it. So like, I'm going to put some code that might fail, okay, inside my try, and then if something bad happens, do this. Okay, so let me save that, and then in my parking lot, rather than assert, I'm going to put an if statement. So if occupied is less than num spots, not enough spots for the car to enter, and of course we have to include that exception up top. All right, and now let's see how many errors I made. None. Magic. All right.
You had occupied less than the number of spots.
Yeah, that's not right. Wait. Yeah, that should go that way.
There we go.
There we go. That still doesn't make any sense. All right, well that should have been. So really it should be greater than or equal to. So if there's 5 spots, there's 5 cars in there, I can't have another car that to enter. All right, and let's rerun that. All right, and of course there's no cars to exit. That was printing out. Let me go back to here. All right, because of that line. All right, and you can see that it's getting printed out. An error occurred when I try to run this now. Okay, and if I remove that offending car enter and I try to rerun this, now things are going to be boring because it doesn't do anything, right? 2 cars entered because there was 2 spots and everything was perfectly fine. Okay, so that's sort of the the catching, right? I guess why don't we just show you what happens if you don't have this try catch block. So if I just run it like that, all right, that should work. Let me just make sure syntactically that works. Yeah, that works perfectly fine. And if I have another car that tries to enter, now it actually crashed. Okay, all right, because there wasn't a catch there to catch that logic error whatsoever up the call stack. Okay, I actually use these a lot in my code. Okay, when something goes wrong or I might do something that might go wrong, I'm going to throw it in a try-catch block to sort of deal with that situation. Let's see, kind of a quick example in my code where I've done this recently. All right, so like in the that parrot system that only 2 of you have submitted to so far, so I am looking for specific files to be submitted, and if you don't do that, I have to figure out what to do. All right, so I have that in a try-catch block. Okay, so like look for this file. If it's not there, do something. All right. It turns out what I've now done is that the file isn't there. I try to figure out did you misspell the file, and I try to rename the file. All right. So like that's one way to sort of recover from a catastrophic error. All right. So that's that. All right, can that disappear? Yeah, catch, parentheses, ... catches all exceptions. So that's another thing that you can use to sort of like catch all sorts of errors. Okay. So is this the answer to everything? And it turns out no. All right. There's sort of certain types of errors which we cannot catch whatsoever. That's always going to break your program, and those are segmentation faults. Okay. What happens is your C++ code is accessing memory it shouldn't be, and then the operating system has to step in and sort of like stop your program to prevent it from doing bad things. All right. There's no way for a try-catch block to actually catch that. Okay. Now, if you put a if you were throwing an exception right before you actually did something that would cause a segmentation fault, that would completely work. Okay, it's like if you were trying to dereference a null pointer, then you could try to throw an exception, and then you could actually recover from that. All right. Other languages, for example, interpreted languages, can catch absolutely everything. All right. So that might be Java, that would be Python, that might be Ruby. A lot of the newer languages have exception handling sort of built into the language, so it works a little bit better. Okay. For most types of errors, exceptions are very, very useful. So like your username and password was incorrect, or the files that you gave my program wasn't the correct ones, I'm going to throw an error, something like that. But sort of like programmer errors would be like accessing something outside the array, and then you can't catch that. Okay? Or dereferencing a null pointer, or doing something incorrect pointer-wise, you can't really catch that in C++. All right? All right, the other thing is, but all code above in stack must be exception aware, meaning you must have catch blocks above to be able to catch that exception. Okay, if that's not there, exception handling really doesn't work properly. Okay, so this is one problem because C++ is a sort of like next version of C, all right? And you can mix C and C++ code together in the exact same executable, all right? Which causes some problems, all right? Because you could have sort of some legacy code written in C, all right? You could be writing your new code in C++. Your C++ is nicely throwing exceptions, except if a C program calls that, exceptions don't exist in C, so there's no way that that can actually work. All right, so that's one situation where a business has to make a decision how these exceptions are going to be handled, sort of like company-wide. All right, talking to people about exceptions and what they do at businesses, my friends at Google say they don't use C++ exceptions because they have code written in C++ and C, and you can't do C++ exceptions in C, so they just use another method altogether. All right, but if a company is all doing C++, then the C++ exceptions might be a way to go. All right, for us right now, at least it's a sort of like this is one way to do it, and there are other ways to do it. Okay, so in our GTest, in our GTest environment, there are lots of other ways that you can actually. If you actually click on this, this is way more ways of using this GTest besides this assert EQ or the floating point stuff. You can also do asserts on throwing exceptions, okay? Because it might make sense in a unit test to make sure some code blows up, all right? If I'm trying to divide by 0, I want to make sure that my class throws an exception, and then my unit testing program keeps on going with that that exception throwing. All right. So the way that you do that is with this assert throw. All right, and then any code inside here. All right, like statement, or sorry, assert any throw is the one we usually use. All right, this statement should throw an exception. If it doesn't, the test will fail. All right. So we try to do something bad inside of here that our class should sort of like raise the red flag and say this is not good, and then that will pass that test. All right. Yes. If you're at all interested in other unit testing things, there's a whole lot of other things that you can use in GTest, but this is one way to do it. All right. So we could write a test like this, all right, with our rational numbers, all right, because remember a rational number is a integer divided by integer, and is anything wrong with a.set denominator equal to 0? That shouldn't work, all right? Because we should never let the user set the denominator equal to 0 because that's not a real number. You can't quite do that, all right? So this is a situation where we might want to modify our rational number class so if they attempt to set the denominator equal to 0, that throws an exception, stops the program, and lets the user or whatever is using that class sort of recover from that in some way. All right? This is sort of just a demonstration that, hey, a rational number is created. The default constructor, I think, sets both the numerator and the denominator equal to 1. All right. I try to set the denominator equal to 0. That says, no, you can't do that. And I'm just making sure that the denominator is still 1, that this one didn't actually change anything. Okay. So this is one way that we can write a unit test to catch an exception in something we've seen before, which is that rational number. Okay. All right, so this is assert. I already talked about this a little bit. Yes. Yes, so yeah, we sort of already did that. Assert value, or value must be true. If value is false, then the entire program is going to exit. Okay. Ta-da! You have no exceptions. All right. So the next, homework or lab? Probably lab. Labs are shorter. The next lab is going to be modifying the rational number class. Good question. I haven't quite thought that through. Let's see. So the homework assignment is due. Is it tomorrow or Sunday? I think it's tomorrow.
Sunday.
It's due on the 11th.
You want it to be due tomorrow.
No.
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 All right, the homework is due Sunday,
Why do you want it to tomorrow?
so that I can give you another assignment.
Nah.
No.
Why do you think?
Sunday it is.
I'm gonna verify that before.
It's the 11th. I promise
It is
you.
11.
With all of you saying that, I question it. Yeah, due date on the 11th. Okay. All right, so that's Sunday. All right, so that's the My Complex class. As you're doing that, you're gonna. Has anybody finished it? I know one person. 2 people have finished it.
Yeah, I sort of.
Alrighty. Well, as you do that, you realize, this would have been good to do before the exam. Oh well. All right. So that's due on Sunday. Next Monday, we're going to talk about exceptions a little bit. I'll walk through modifying one of our classes already. Are there any situations for complex numbers that you shouldn't be able to do? Well, we have divide in the complex number class, right?
Yeah.
All right. So we could write an exception in there if they try to divide by 0. That prevents it from happening. Okay. So I'll probably demonstrate that on Monday, and then lab for next week. I'm not sure when it'll be due. Probably Wednesday. It's not that difficult. All right. Is to modify the rational number class to start throwing exceptions.
Give us a week. I like a weekend without homework. It's nice.
Well, sure. That's fine. You want me to move back the homework so it's due tomorrow night, and then you have the weekend for free?
No.
No.
All right. Well, then I could do that.
It's a trap.
It's not a trap. Then you have the weekend free.
No, it's okay.
I'm cool. What about next week? The homework next weekend. We do the lab, have it due on Wednesday, and then nothing until like,
The following.
yeah.
I like that.
I don't know about that. I'm
And
gonna
then we can have the next homework assignment due like next Thursday.
all right. I will think about it and I'll look at the topics and see how much time we need.
Alright.
All right.
It was a break.
There's no breaks.
My brain's
I've
hurt.
learned that.
This is already June 8th. All right.
It's my mom's birthday.
we gotta-
Made me fail a test on my mom's birthday. How's that make you feel?
I don't know. Because we have a bunch of more topics to go through.
Jesus.
Okay.
I had exam today.
What?
That's the second exam today. To tell you.
All right. We have a bunch of more topics to go through, and this is where it starts to get a little crazier.
That's scary.
All right. The core part of what you really need to know for this class is really what this exam was on. All right. All of this stuff that you've seen so far, you will see multiple times in your careers. All right. The stuff we're going to cover from the rest of the semester on, you will see a few times in your careers. But like pointers, classes, yeah, like forever you're going to be seeing that stuff. Okay. All right. Why don't we stop there? You're welcome.
Appreciate that.